Hello, my darlings. Okay, today we're going to learn our last new rule. This is the chain rule. Before we do that, I would like to find the derivative if y equals the quantity x squared plus 3 squared. Now, remember, that means that this is really x squared plus 3 times x squared plus 3. Now, we could do the product rule if we want, or we could just multiply that through, right? That would be x to the fourth plus 3x squared plus 3x squared plus 9. So now we know y equals x to the fourth plus 6x squared plus 9. Now we're ready for the derivative. The derivative of y is called dy dx equals the derivative of x to the fourth is 4x, decrease the exponent by 1, so it's cubed, plus, make sure that 2 is multiplied by the 6, 12x, our new exponent is 1, so we don't need to write it, and the plus 9, the derivative of that is 0. And this is a perfectly good answer. Now, we've already talked so far this year that right now we're just finding the derivatives, but when we start to use the derivatives for things, we're going to want them in factored form. Now, there is a reason that I want to do this, but let's just factor our answer. And it's only a binomial, and it looks like there's a greatest common factor of 4x. So if we factor out of 4x, that's going to leave us with x squared plus 3. And that binomial is not going to factor anymore, so here's our derivative in factored form. Now, I want to introduce you to the chain rule. Now, some professors or textbooks will also call this the outside-inside rule. Some actually call it the inside-outside rule. So here we go. If we have a function y equals f of g of x, notice it's a composition function. There is an outside function and there is an inside function. Same thing down here. This is the inside and f is on the outside. Okay, so what that means is our derivative y is going to be dy dx equals, we take the derivative of the outside function, we keep the inside function, times the derivative of the inside function. Okay, so the same thing happens down here. It's f prime of the original inside function times the derivative of the inside function. Or in other words, step 1, take the derivative of the outside, keeping the inside the same. And step 2, we multiply by the derivative Now, when you go to simplify, you only need to multiply monomial terms. So let's try one. Okay, we're going to find dy dx. Now, this is the function that we found the derivative of at the beginning of the video. Okay, it's the same thing. So we're going to look at the outside function. Do you see that the outside function is something squared, right? So that's like having f of x is x squared. And our inside function is that x squared plus 3. So when we go to take this derivative, it's going to be called dy dx. When you have something squared, you bring down the 2. We're going to keep that inside, and we're going to decrease the exponent by 1. So it's just going to be to the first. So the inside, we're going to keep that the same, x squared plus 3, times the derivative of that inside. The derivative of x squared plus 3 is 2x. Now, we have one more step because we do have monomial terms. 2 times 2x is 4x times, keep the inside, And that is the same answer we got earlier, but notice it's in factored form. And that's the nice thing about the chain rule. The chain rule will give it to you factored. Sometimes there's a little more factoring that can happen, but it's definitely closer to being factored completely than any of the other methods that you could use. Whether you squared it out or whether you use the product rule, you will definitely come closer to being completely factored this way. I cannot always promise you that the binomial in here or the trinomial that's there isn't factorable, because it's possible it is. But you're at least one step closer. Okay, let's try another one. So again, in this first function, f of x equals the quantity x squared plus 2 squared, the outside function is squaring. So we're going to bring down the 2. We're going to keep the inside, and the new exponent is 1. We keep the inside, that's x squared plus 2, times the derivative of that inside is 2x. Now we're going to rename this f prime of x. We do have monomials. 2 times 2x, that's 4x, times the quantity x squared plus 2. We have our derivative in completely factored form. Let's try another one. So the name of the derivative of f of x is f prime of x, or the derivative of f of x. The outside function, again, is still squaring. So we're going to bring down the 2. We will keep the inside, and we're going to decrease the exponent by 1. So now I'm going to write the inside times, now the derivative of 3x squared plus 1 is 6x, right? And the 1 becomes a 0. We're not done. The derivative of f of x, we have the monomial 2 times 6x is 12x times 3x squared plus 1. Now I'm going to remind you, do not distribute that 12x through. Do not distribute the 4x through. You're going to make your life more complicated. Okay? This is your answer. Stop here. Let's look at the third one. So now the derivative of f of x is going to be f prime of x. Now if we look, our outside function is raising to the 6th power. So when we take the derivative of something to the 6th, we bring down the 6. We're going to have to keep the inside, but our new exponent is 5. Now I'm just going to bring down my inside times the derivative of 3x squared is 6x, plus the derivative of 2x is 2, and the derivative of the negative one, is 0. I have no monomials to multiply. I am done. Okay, next up, we've got h of x is the square root of x to the 4th plus 1. Now, when I look at this, I definitely see an outside and an inside. The outside is the square root, and the inside is x to the 4th plus 1. But in order to take the derivative of that, we need to realize that this is the quantity x to the 4th plus 1 raised to the 1/2. That when you take the square root, that's raising to an exponent of 1/2. So h of x, the derivative is h prime of x. Now when we take the derivative of raised to the 1/2, we bring down the 1/2. We're going to keep the inside, and 1/2 minus 1 is negative 1/2. Now I'm going to keep my inside, x to the 4th plus 1, times the derivative of x to the 4th plus 1 is 4x to the 3rd. Now we need to simplify this out a little bit, okay? So we're still going to have h prime of x equals, I have 1/2. That means there's a 2 in the bottom. Now you see this negative here? That means the x to the 4th plus 1 is in the bottom, and the 1/2 means we have a square root. We also still have a 4x cubed in the top. That times 1 is just going to give us the 4x cubed. We are not finished because 2 goes into 2 once, 2 goes into 4 twice, and now our derivative h prime of x is 2x to the 3rd over the square root of x to the 4th plus 1. I know it's tricky when you start getting into all these fractional and negative exponents, but that's the algebra, and we know the hardest part of calculus is the algebra. Speaking of those difficult exponents, let's do this one. We have y equals the quantity 2x plus 1 over 2x squared. I would suggest, because you don't want to have to do a quotient rule for this, okay? I would suggest that you rewrite this as 2x plus. Now these parentheses are necessary because the 2 and the x are raised to the negative 1. That's how they got in the denominator of that fraction, okay? Now it should be a little easier for us to use the chain rule. So the derivative of our y is dy dx. Our outside function is squaring, so we're going to bring down the 2. We're going to keep the inside, and the new exponent is 1. I'm even going to write the inside the original way. Okay, it doesn't matter which way you write it. Times. Now the derivative of 2x is 2. Plus. Now this derivative has an outside and an inside. This is a double chain rule. Because now the outside function is raised to the negative 1. So I'm going to bring down a negative 1. I'm going to have to keep the inside, but my new exponent is a negative 2. Now on the inside, I'm keeping the 2x times the derivative of the 2x is 2. Whew. All right, let's see what we've got here. dy dx equals 2 times, and we've got the 2x plus 1 over 2x. So if at this point you had written the 2x to the negative 1, this is the point where you would change it to 2x, okay? Times, we've got 2. Now that plus really should be a minus, shouldn't it? Because plus a negative 1 is a minus. And a negative 1 times 2 is a negative 2. But this exponent is going to have me put the 2x in the bottom and square it. And guess what? We're still not done. Because now we have dy dx equals 2 times the quantity 2x plus 1 over 2x times 2 minus, now here's the thing, this denominator here is 4x squared, but 2 goes into 2 once and into 4 twice, so this is going to be 1 over 2x squared. And now we have finished our algebra, and there we go, my dears. All right, chain rule. Derivative of the outside, keep the inside, times the derivative of the inside. You've got to know the chain rule. Have a good day, guys. Bye.